Hi everybody, here we have a finished Cananka board. So first thing that you will notice is as compared to just any standard head, you will see that left cutout is a bit bigger, and on right side we have additional cutout that is not present on head template. Reason for this is that when you use just a basically standard Raspberry Pi 3 case, you are not going to be able to fit it unless you have those cutouts. First one is here for these snaps, so they can fit in place, otherwise they would just hit the board. And the second one is for this piece of plastic that I frankly have no idea why would anybody put there, but it is there, so it's either grinding it out or just going around it. And of course this side panel we can just pop in. So now when you have a finished product, this is how it would look like. So it fits perfectly into the case. Okay, let's slowly get onto the board. So it takes a bit of time to pull out. Okay, so this board, we will see first that it has one isolated side, so side that communicates with cruel world outside. So this is below this line. Above this line we have non-isolated side, which is close to our Cananka. Biggest chip immediately noticeable on non-isolated side is MCP2515. That is our main CAN chip, and this is the chip that actually takes care of the protocol stuff as far as CAN goes. We are connecting it to Cananka, of course, over SPI interface. On top, we do have, let's say, notes which pin is which one, so it's easier to track it via multimeter. Next to it, additional chip is a small EPROM. So this EPROM is actually something that is going to take care of our auto configuration and everything related to it. Then we have, let's say, a small bunch of supporting chips, so some resistors, some capacitors, nothing fancy. Here we have our isolated CAN transceiver. So this is ISO 1050 something chip. So this chip is actually one that will convert CAN takes and RX lines coming from MCP2515 to the lines for CAN high and CAN low that are present on the other side. And here, of course, we are just putting it directly to connector via one small set of Zener diodes for protection. Connector, of course, is a sturdy one with separate pins. So we have a, let's say, semi-standard layout, ground, low, high, and plus. On top we can add termination resistors if we wish. So they were added on top. Although they do mess with visual identity a bit, that makes it visible when this is in case, where the only thing you see is actually top. You are going to immediately see whether your device is terminated or not. Here on side, something that's usually not very visible when board is on is a couple of pads. You can basically on them check what are the standard voltages and whether everything is okay. This isolated DC to DC converter is what actually powers the bottom transceiver side, the isolated side. Reason for that is we don't want to depend on any power that comes or does not come from CAN side. So we want to have our own source of power, and Raspberry Pi is actually powering this one from non-isolated side, and then it becomes isolated power supply. Of course, if we do have power coming from CAN bus, we can essentially put it in, and that goes first over this fuse. This fuse theory is pretty much the same as for resistors. We put it on top so it's immediately visible. Are we using additional DC to DC converter to power Raspberry Pi or not. So if it goes across this fuse, we have, of course, quite beefy DC to DC power converter, and we have a back powering circuitry that is actually taking care that we are not damaging Raspberry Pi, even if other power supply is plugged into it. And essentially, if you are using Cananka, in such manner that you are powering stuff in, so you would go power stuff in, it would go over DC to DC, you would power Raspberry Pi, and then in turn Raspberry Pi would power your MCP and this other side, and go over DC to DC to power the transceiver. So it's kind of roundabout way of doing things, but it enables for same circuits to be used for both when you are back powering and when you don't have any power on device. Here we have also a set of diodes. Through hole was used, so we can mount them on top so they are easily visible when everything is packed, because remember, bottom side is not visible at all. Here we have whether output power is present, whether input power is present, and whether external power is present. External power is obvious one. This one input means is isolated, non-isolated side from Raspberry Pi getting power, and output means it's isolated side getting a power. Of course, we have RX and takes where we can sort of snoop whether anything is happening on CAN bus. Since these LEDs are passive, they are much less bright than any other LED here. And of course, we have our oscillator also on the top. Reason why I place it on the top instead of using some SMD on bottom is because I just hate soldering SMD ones. So this seemed like a nice way of dealing with that, and also it enables you to change clock frequency if you ever have to. Do notice that this one goes up to, I think, 25 megahertz. By default it's 16, so there is some room to grow here. So that is just a short overview of Cananka.